So, welcome to Engineering Tomorrow's Electric Vehicle Event Day. We are so excited to have so many schools live with us. If you can, please turn on your cameras. We'd love to see your students' faces and your classrooms. We have our ET staff here with us today, but
Yeah.
our main star of the day is Mr. Milton Davis, who's going to
Is
be
that me?
leading. Yes, it is you. Going to be leading our event today, and I'm going to pass it off to him. Just a reminder, we love student engagement. I know Milton's going to be participating in a Slido. We're gonna make sure that our comments are on topic. If you cannot access the Slido, please feel free to type in chat with your comments and your questions. And let's get this day rolling. Milton, you can take it away.
Oh, I love that. Let's get rolling. Engineering tomorrow. We are so excited to have our electric vehicle day. This is going to be an absolute blast. Hey, I can't even contain myself. What are we doing? So we're going to develop an electric vehicle, and we're going to develop that electric vehicle because our resources across the country, our energy resources, hey, they're depleting, but you get to help today solve that problem by developing your own EV as a team. Maybe at the end of the day, once you're all finished, we'll get a little competition going, right, Monica? Let's do this. This lab was developed by very, very good engineers, Kelsey Farr, Eric Einset, who's just like an absolute genius, and some other students, because we want the lab to relate to you. Now, you're probably wondering, like, who is this guy? Who's talking to me? So let me give you a little bit about my background and how I got involved with Engineering Tomorrow and what I know about EVs. So this is what I do. What I do is I'm an aerospace engineer, right? I design satellites. Hey, satellites are a form of electric vehicles, especially if they use electric propulsion. But if I had to give myself one title about what I do, I love to solve problems. And you have a great problem and challenge today in developing that electric vehicle. How did it start for me? Well, I'm born in Gary, Indiana. I saw some folks from Indiana, some Hoosiers in the chat. Shout out to you all from the Midwest. My parents didn't go to college, but my dad was a welder at an oil refinery, man. And he just really taught me and pushed me to solve problems across the house. You know, can you help me fix the refrigerator? Help me fix the car, fix things around the house. One, hey, that kept me on the straight and narrow. And two, it just ignited my passion to solve huge problems. So when I was blessed to get the opportunity to work at NASA, it was a game changer. There were so many different problems to solve. I'm highlighting this mission called the Magnetospheric Multiscale Mission, where we sent 4 satellites into space to investigate the magnetosphere. And the magnetosphere is what allows us to have life on Earth, and why Mars doesn't have life, because the magnetosphere protects us from just crazy solar radiation. So we wanted to discover that. And my favorite electric vehicle, if you're asking, I got two of them. One is Ingenuity. I just think helicopter on Mars based off of solar energy and a battery, can't beat that. I think that's my favorite electric vehicle. Hey, but I got a question for you. If you jump into slido.com, gives me a little opportunity to engage you some. What is your favorite vehicle, right? What is your dream car or truck? So check this out. If you go to, thank you so much, www.slido.com, type in those numbers. Thank you, Jill. And look at the power team. 377-9112. It gives me an opportunity to engage you some, and maybe some of my ET friends could help make sure that this poll is working. Yeah, we got some folks typing. Excellent, excellent, excellent. Good. What's your dream car? It could be an EV. Maybe it's not an EV. What is your dream? Oh, a Mercedes. Oh, Jeep Wrangler, the G-Wagon. Oh, someone better practice engineering. We got some folks that need to go into like computer science, right, Constance? Right, Megan? Mercedes, right? The Oscar Myers hot dog. Okay. Oh, the Hellcat is nice. The Hellcat, is that a Hemi? The Rivian, there we go with an electric vehicle. They got the Rivian, got the Tesla Cybertruck. Hopefully they bring that out, right? Hey, shout out to GM. GM is working really hard on some electric vehicles. The Ultimatum battery, you're gonna hear more about that in this presentation. Oh, that Lambo. I love that Lamborghini Aventura, and they're coming out with a Lamborghini EV as well. Excellent, 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 nice. All right. So you got that part. I got some examples of some other electric vehicles. I see the Bentley in there, Dr. Anthony from Bladensburg. There's some other examples of EVs. I think traditionally we think of cars, but did you know there's trains and trolleys, UAVs, right? Drones. Did you know this as well? That when you're on campus or you're in a city, those electric bikes, those electric scooters, my favorite, RC cars for sure, space vehicles that operate off electric propulsion, those are all electric vehicles, right? And I know some of you all are thinking, man, you know, if everything becomes electric, I got this question from someone out in Queens High School, right? If everything becomes electric, isn't that going to tax the grid? Well, I thought one way to take a look at it is, why don't we compare it to what? Our appliances, right? So when you think about it, you got the Tesla Model 3, you got all that Ford Mustang Mach-E is nice. They're not, you know, producing and outputting or needing too much more electricity than your common appliances. Not to mention with battery technology and solar technology, hopefully becoming much more efficient by 2035, I think we'll be able to balance it out. Hey, I love that Ford F-150, that's a nice truck. So what's the history and how did we get here, right? Well, first of all, the electric motor was developed in about 1828. And then in 1891, you had electric vehicles come along. But electric vehicles actually were produced before what we're going to call gas-powered cars and internal combustion engines. And you'll see more about the history in this next video. So what I want to do, we're going to watch this video. It's going to give you a great intro to all things EV. And then I have a nice challenge for you afterwards. I need you to come up with as much advantages to electric vehicles as you can. And just be fair, disadvantages. See what you hear, okay? So we're going to play this video and then we'll be right back.
I was invited here to Munich by BMW, the sponsor of this video.
Oh, I got to ask this. How's my audio? Can we hear that? Good.
Perfect.
Thank you.
To find out why the future of cars is electric.
But electric cars are actually nothing new. They date back to 1832, well before the first gasoline-powered car. In fact, the first car to go faster than 100 kilometers per hour was, in 1899, an electric one, called the Jamais Content, meaning never satisfied. But people were, apparently, satisfied with electric cars. By 1910, they were almost twice as common on American roads as internal combustion engines. But then came the Model T, which at $650 was significantly cheaper than comparable electric cars. And as gas stations popped up around the country, they could be quickly refueled, allowing you to travel farther, faster, and cheaper than electric cars, which took a long time to recharge. So by 1935, the electric vehicle had been commercially obliterated. But electric cars were still useful for some things. In the vacuum of space, an electric vehicle was the obvious choice for the Apollo lunar roving vehicle. It was a single-use vehicle due to its non-rechargeable silver-zinc potassium hydroxide battery, and it had a range of just 92 kilometers. But the astronauts never needed even half of this range. At the Munich Olympics in 1972, to lead marathon runners in their race, BMW created an electric version of its 2 Series car. The car ran on 12 large car batteries for a maximum range of 60 kilometers, or 37 miles. This demonstrated the benefits of electric vehicles. They can run quietly with no emissions. It demonstrated their limitations. With the battery technology available at the time, electric cars were expensive and short range, impractical for everyday use. So why are electric cars the future? In 2020, BMW is launching the iX3 all-electric sport utility vehicle, and they plan to have 25 electrified vehicles in their fleet by 2023. A lot of their concept cars, like the Vision M Next, are electric vehicles, and they have a Formula E car which can now run a whole race on a single battery pack. This is all made possible by developments in battery technology. Batteries have gotten a lot better, particularly with the introduction of lithium-ion batteries. First used in mobile phones about 30 years ago, lithium-ion batteries have almost 2 times more energy in the same volume than the next best battery chemistry. Because of their use in many consumer products like phones and laptops, their manufacturing costs continue to decline, driven by manufacturing and supply chain optimization. Over the last 3 decades, the energy density has increased both per unit mass and per unit volume, while the price has plummeted. This is unlike internal combustion engines, which, after a century of development, have few areas left for improvement. And the reality is, you don't really travel that far in a car. The batteries available today are good enough for all but the longest road trips. In the US, 99% of trips are under 160 kilometers, or 100 miles. And electric cars are just better vehicles. Here are my top 10 reasons why.
First, more torque from a standstill.
Thanks to the batteries under the floor, they have a low center of mass and so better handling.
Since you can drive electric motors independently, you can have precise control over each wheel for maximum traction. Electric cars are quieter. Electric cars are cheaper to run than gas cars because gas is more expensive than electricity for the same distance traveled. Electric cars are more efficient than gas cars, both in converting stored energy into energy of motion and in regenerating some of that energy in braking. You never have to visit a gas station because you can recharge.
Why am I hearing talking?
There's less maintenance, fewer moving parts, no oil changes, and the brakes wear out less often thanks to regenerative braking. And depending on the source of electricity, in my case solar panels, electric cars don't produce any CO2 at all, so they don't contribute to climate change.
Plus, as cars become essentially computers on wheels, electric vehicles are leading the way towards self-driving cars.
We're gonna start our ride in an autonomous vehicle, my first time ever.
All righty, video's over, and you all should have caught some good advantages and disadvantages. Hey, just type this in the chat real quick, those of you who have access to the chat. What are some advantages that you heard for electric vehicles? What are some advantages? What are some good things? What are some good things you saw? Oh, look like someone unmuted. The cheaper, that's great. Lower center of gravity, that's excellent. Lower cost per mile, better torque, nice. Cheaper to run, no air pollution. Hey, we're gonna talk about that a little bit. Efficient, fossil fuels, nice, excellent. Okay, Wise, Northbrook, excellent. Okay, great. Henry A. Wise, Energy Institute, that's an excellent school name. Nice, yeah. Cheaper, excellent. This is great. Saves gas. Oh, nice. Killing it. You're killing it. All right. How about some disadvantages? Did you catch anything like? You got to think about this. The video didn't talk about disadvantages, but really think about this. What could be a disadvantage? Range. Yeah. Range. Battery life. Yes. Yeah. These lithium batteries, there's some concerns about how long they last. That's not, can't go as far. The battery, nice. Yeah. Repairs, I like that. Yeah. Charging takes longer. That's one of the keys, right? Oh man, this is good. We're going to disposal, the environment, materials, very nice. This is really, really good. Okay, you're good. So let's walk through some advantages. You know, I don't know if you all, but I work on my own cars still, and it is just so many parts, right, Brad? I mean, you got all these parts, and just trying to fix every single one. These electric cars, very simple. You got a charger, you got a battery, you got a motor, you got a controller. Very simple to fix, less parts. Anytime a system has less parts, there's less chances for failure. Failure rates, that's important, right? There's also the cost of fuel. I mean, to make this fair, if we had to say how far can an EV versus a gas-powered or internal combustion engine travel, on $1, the electric vehicle would travel much further. Hey, Alexa, malfunctions, excellent answer. Much further. So you have that part about cost. And then one of my buddies out from Brummel Academy in Meadowville, Indiana, asked this question: why does the battery go into the back of the car, into the base of the car? Well, one nice thing about electric vehicles, Their batteries are situated at the base, and sometimes their motors are situated inside the wheels. All of that really increases its ability to have a lower center of gravity. And if you're an American football fan like me, you know, you're a running back, you got to have a low center of gravity to power through, right? You got to have a low center of gravity. It helps it on turns. When it's turning, there's less chances for it to topple and flip over because of that low center of gravity. And because the batteries are so heavy, between 1,000 and 2,000 pounds, it really helps with stability, right? There's also another really, really great thing. It's regenerative braking. Now that's a complicated word, but I'll break it down like this. You got a motor, and inside of that motor, you have some magnets and you have some conductors. When electricity flows into a motor and you have magnets surrounding this field, you produce what they call electromagnetic force. It's what causes the motor to spin. That's electricity causing the motor to spin. With these cars, electric vehicles, as the car is moving, it already has momentum. It's already moving. It already has inertia. So as it's slowing down, you don't need electricity to slow it down. So what you can do is, instead of utilizing electricity to power the motor, now, since your motors are already spinning, they're producing electricity. And you can use that to charge the battery or to power lights. That's regenerative braking, charging by motion. Isn't that deep? That's deep. And then another thing people talk about is, man, yeah, you know, you guys hit the nail on the head. Some of these electric vehicles, they don't have a lot of range. You just don't pull up to a gas station. Pull up at the gas station, you're there about 5 minutes and you're good to go, right? You can even go in a gas station, get a snack, and bam, you're done filling up. And that's different with electric vehicles. So here's my next question for you all. Which EV out there do you think has the longest range? Which has the longest range? Which one can travel the furthest? You can place this in the chat. Is it, or you can try to use this Slido poll. Is it the BMW? Someone said Lucid. We got some Teslas in there. All right, the BMW i3. What about that Chevy Volt? Shout out to GM. Shout out to, you're gonna hear the great Telva present this afternoon. I'm so excited about it. Tesla's coming in strong, nice. The Fit, hey, you're just throwing in car. Yeah, excellent, yeah. If you said Lucid, you are correct. Oh, look at you all. Oh, there it is. They're active in the poll. I see them. There you go. Nice. This is great. I want to shout out my buddy Constance and Megan and Jillian, all supporting here today. Jen, Scott. Lucid Air is coming in strong, and you all are correct. It's crazy. They developed a car that travels between 380 and 500 miles. Now, I live in Maryland, but I'm from Indiana, as I told you. That's about 680 miles. So if I travel and just kind of recharged in Ohio, I'm good to go. But a lot of times that recharge time on 240 volts, that could take 10 hours. It means I have to stay in a hotel. I don't want to have to do that. So what they've come up with, Tesla's come up with, and some other companies are producing, is superchargers. They can charge that battery, a 480 volt DC, in 60 to 90 minutes. Hey, that means I can just go to IHOP and we're done, right? All right, so that is our charging. And then check this out. All these major interstates, that's what you see in red. Look how many charging stations you have across the country. So I think you can travel across the country in an EV. I wouldn't mind an EV. Maybe I wouldn't mind an EV. Maybe somebody can make that happen for me. Okay. All right. But what about the battery chemistry? What type of batteries do we have? I thought there were only lead acid batteries for a long time. That's the type of batteries I used to use in my remote control cars. But then nickel metal hydride come around, and that is a really, really good battery, and it's really safe and it lasts really long. But it doesn't have the energy capacity, the energy density to really, really be a viable option for many electric vehicles, though they do use it in some. Lithium-ion batteries have so much storage capacity that they are really what's driving the technology today. They have advanced electric vehicles to the point where You're not just using them in EVs. They're in your phones, in your tablets, right? They're in so many different devices. Let's break down the chemistry a little bit, right? Like, what's really a driver? There's some research in battery chemistries that show these different groupings of materials, and you can really look at how long they last. What, like you all talked about, you're concerned about how long they last versus that energy density. But it turns out, you got your car battery, that's lead acid. You have your nickel cadmium, that may be, what we have in your ET kit and what I have in my RC car. So I'm still not using LiPo batteries. And then, you also have your standard alkaline, which you have, and then these lithium batteries. And the big thing you see is that in these lithium batteries, look at that energy density. But on the flip side, look at the cycle life. That's something we need you all to help improve upon. How do we improve lithium batteries, or how do we find some sort of alternate to lithium batteries? And then check this out. What are some of the concerns? I got this question from Mott Hall the fourth in Brooklyn, New York. What are some of the concerns? Well, the labor practices in mining, different materials are concerned, right? There more materials than lithium ion are involved with developing EVs. There's environmental impacts. There's carbon emissions. If I'm missing something on this page and you know some concerns, type them in the chat. What other concerns do you know that we have with lithium batteries? There's toxic waste, right? Hey, welcome Newark, welcome Porter High School. But there's some ways that we can mitigate this as well. Hey, Phelps Ace, we can improve our battery recycling for sure. Maybe if we shift to smaller cars, we won't need to expend as many of this natural resource. And for sure, there's alternate forms of battery chemistry. There's sodium base. Sodium, if you look at a chemistry table, sodium is really close to lithium. It also could be a good candidate, same properties, and is found nearly everywhere on the earth due to the abundance of seawater. And then you have this aqueous magnesium, which it definitely has some issues, but it has a very, very high capacity and an additional valence electron. And then GM has this Ultium battery. I won't give it away because Telva's probably going to talk about this, but this may be the game changer, okay? So how does it work? Well, first, when you're running that battery, you're discharging. You have these, electrons flowing through the battery. And this is going to be very similar on your project where you're going to use a solar panel, right? And then you're going to charge a rechargeable battery. We've given you a rechargeable battery, and we give you a non-rechargeable battery because we want you to finish the project today. We want to see it today. But there's a discharge part and there's a charging part of it. Now, when discharging, the battery provides power to the load via electrons flowing from the negative terminal of the battery to the positive side. And at the same time, these positively charged lithium ions move from the negative anode to the positive cathode. And then you flip that whole process, and that's what produces your ability to charge, right? So we've gone through all this good background on electric vehicles. I know you're probably thinking, Milton, when are we going to get started? Let's do it. What are we going to be doing today? In today's lab, first, you're going to charge a rechargeable battery using a solar panel. And maybe you're thinking, hey, Milton, hey, in my neck of the woods, there's clouds outside. I don't know if I can charge. Well, we gave you a non-rechargeable battery as well. But you may be able to take advantage of powerful lights within your school to also charge the rechargeable battery. And then you're going to have the ability to use that renewable energy or the non-renewable energy we've given you to develop your own electric vehicle. I know it sounds like a challenge, but we've got a cheat code for you. That cheat code is called the engineering design process, where you start with a little research. We've given you a little bit of research already. You develop a design. I'm old school. I still like to make my design on a sheet of paper because I know if I'm designing on a sheet of paper first, when I build it, I'm going to have less issues because I thought through the problem. I'm big on problem solving. And then you're going to build, and then you're going to test. And we've given you enough materials where you can fail multiple times and keep testing over and over again. There's power in failures, for sure. I've been blessed to obtain a couple patents. They all came from mistakes. that I had to solve a problem, right? Had to solve a problem, okay? So here are your materials. Oh, you know what? Let me give you another view of these. Let me give you another view of these. Let me give you all another view of these materials real quick, okay? So you got your battery here. You got your solar panel. Hey, I got a battery and solar panel right here. So you got your solar panel right there. You have your battery, and we've given you a battery holding case, right? And then if you use this and utilize, we've also given you a diode. Somebody type in the chat, like if you're using a solar panel and you have a battery and you have a battery holder, why did we give you a diode? Why did we give you a diode? What is a diode, right? Why did we give you this? I can see some of you all pulling out your materials right now. That's excellent. So we gave you a diode, and this is what you can use to charge the battery once you place it in a battery holder. Let's get rid of that. We also gave you some materials to make your own vehicle, some wheels. You know, we've given you some axles, right? We've given you a motor and a fan. This allows you to say, hey, am I gonna have a vehicle where I'm gonna power it based on air, right? Air propulsion, or am I gonna have a vehicle that I'm gonna directly use my motor to transfer torque and rotation to some wheels? And you can see I have a pulley system on these wheels. So I'm just trying to spark some ideas with you all today. All right. So this is again showing that electric circuit model, right? And it's showing you how you use the diode. What the diode is going to do is make sure that electricity only flows in one direction. But we know we don't have a lot of time. So we gave you a non-rechargeable battery as well. So in parallel, you can get started developing that vehicle. This is showing that charging station setup. And this is showing you all the parts that we've given you: gears, pulleys. You know, we've given you the battery holder, the rechargeable battery and a chargeable battery, and your wheels, right? You can make any vehicle you desire. Now, this isn't everything. This is not everything. So in the chat, if you can hear me, outside of these parts, what other parts do you need from your classroom or from your home to make this EV? What else do you think you need? This is the research. Start thinking about that. What else do you need to make this vehicle? There you go, Northbrook. Cardboard, tape. Yeah, yeah. Hey, look in your kit. We may have given you some utilities. I think we gave you some glue and some tape. But those are outstanding. Cardboard for the base. There's a lot of different things you can use for the base. Excellent. Thank you, Academy Charter School. Thank you, Henry Wise and BHS. Good feedback. Thank you, Brummel Academy. Excellent. Wood. You could use wood. I use wood on mine. That's great. I didn't show you that. I'll show you now. Here you go. Here's a car I developed that has a little wood for the base, right? If you have some, and I'm taking advantage of a pulley system that will operate on top of this car here, right? And you take this pulley and we transfer energy directly from the motor to another pulley as we're moving it. Hey, I'm just throwing out some ideas. I will say you don't have a lot of time, so don't make it too complicated. But hey, great feedback. Then you're going to build this EV, right? That's the next step. You're going to build it. So let me give you some examples. I love the craft sticks, Charles Herbert Flower. Shout out to you all, one of my favorite schools out there as well. You got your wind powered car and with multiple batteries. Some people use bottles. Hey, why not? Nice, lightweight. Maybe you make the type of car. I love the mousetrap idea, Phelps. Maybe you make the type of car that can operate in water and on land. Yeah, you're killing it. We're just giving you some different examples here as well. Maybe you make a water-based vehicle. Electric vehicles aren't limited to cars. I love this. I love this video as well. All right. And then there's some optional extensions we have for you. So we talked about that. How do you take advantage of more batteries? More batteries give you more power. What's the disadvantage of more batteries though? Think about that. Type that in the chat. What's the disadvantage? You can hook them up in series or parallel. Series is going to give you more voltage. Parallel is going to give you, more current. What is the disadvantage though of using heavier? Excellent. Needs more time to charge. Nice. Wasting materials. Sharp group. Here's another optional extension, mechanical advantage, right? And maybe that motor in its configuration just doesn't have enough speed, or maybe it just doesn't have enough torque to give you what you need, right? So you can choose that. You have gears that we've given you where you can gear up or you can gear down. So if you think it needs to be really, really fast, hey, maybe you gear down. If you think it needs more torque, get a little more acceleration, or the car is too heavy for the configuration you have, hey, make your transmission so you gear up, get a little more power, right? That's up to you. But what is the risk of utilizing gears and pulleys? What do you think a disadvantage of that is? What could be a disadvantage? You only got to, you know, we're going to come back in about a couple hours. What do you think a disadvantage is? Oh, I'm sorry, Dr. Frederick Fisher, you all can't hear me. Hey, we got a video though, where we can send it to you. Disadvantages. Well, friction loss. Excellent, Chris Lynch. Excellent, that's excellent. Nice. Another big one, and I know this is a deep question, it's time. It takes time to get all this stuff to align right. It takes time. So that's something you got to think about as well. So if you enjoyed this, video, this recording that we have right now, this presentation, you may want to get into electric and hybrid vehicles. You may like vehicle design. Maybe you take on some of our labs with design, 3D printing and medical devices, or 3D printing in production, and you learn a little bit about computer-aided design so you can make your own designs. Or maybe you realize that electric vehicles need better aerodynamics. Hey, we have an aerodynamics lab that walks you through, next year we'll have some aerodynamic simulations in there so you can learn how to improve it. One thing about electric vehicles though, is really cool. Almost every single engineering discipline is involved. Electrical engineers, think about, we need to improve the battery chemistry. Chemical engineers for chemistry, right? Mechanical engineers, you got to have a good lightweight structure. Materials, how do we develop lightweight materials that are also strong? And then this entire energy system, okay? Phelps said we learned about circuits. Oh, nice, and how they're structured, excellent. So, and this is a circuit as well. So if you learned about circuits, you got to close the circuit in order to get this car to work. All right. Hey, I've really enjoyed this intro with you. I cannot wait to see the vehicles that you're all going to develop. I'm going to hand it off to my buddy Monica to talk to you all about next steps.
All right. Well, that concludes our introduction portion of the EV Day.